Good afternoon. I'm Nicholas, and today I'll be sharing with you my final year project, which is AI for Healthcare, focusing on depressive social media tags. Here are the tables of contents. Firstly, we will look at the introduction and the objective of the project. Then we will explore the task, dataset, and the model and framework used in this project. We will then move on to discuss the different natural language processing tasks. Lastly, we will conclude the project. We will now look at the introduction and the objective of the project. Depression existed in this society for many years. Nearly 300 million people in the world suffered from depression every year. With technological advancements, social media platforms serve as a place for depressed personnel to seek help. Social media helps to detect depression by analyzing posts on social media platforms because this has become the new norm to express one's feeling and process social media data can take place quickly. Hence, authorities are able to intervene at an earlier stage. Focus of this project will be to leverage on the use of deep learning and NLP to do an in-depth analysis on depressive social media contents. Specifically, we will begin with the more common task of predicting whether a particular text contains sentiment of depression. Then we will dive deeper to create a depression metric and predict depression scores for all of the data that are labeled as depressive content. Lastly, we will experiment with the more uncommon task, which is the emotion cause pair extraction, which is to determine how accurate the model can extract the emotion and the cause of depression from text clauses. Moving on to explorations. The NLP tasks explored are emotion classification, emotion intensity prediction, text summarization, and emotion cause pair extraction. The datasets explored are the Twitter dataset and the Reddit dataset. We will be using the sequence models and the transformer architecture. They include a long short-term memory LSTM, gated recurrent unit GRU, and the bidirectional encoder representations from transformer BERT. The PyTorch framework is used to incorporate more flexibility and customization in building the models. Moving on to tasks. For the first task, we will be doing emotion classification, which aims to classify if a text is depressive or non-depressive. The pipeline shows the brief outline of how this classification task is being carried out. For this task, we will be adopting two approaches, the sequence models LSTM and GRU, and the transformer model BERT. The slide shows the hyperparameters held constant for the training of models. These are the results for this classification task on two different datasets. Clearly, BERT performs the best for both datasets in terms of area under curve, AUC. For the second task, we will be doing emotion intensity prediction, which aims to estimate the magnitude of depression from text. From this task, two methods will be proposed to obtain the depression intensity score. Method 1 will be using a combination of symbolic and subsymbolic approaches to obtain the depression score. Method 2 uses the simpler method of just calling the Centric API on depression identification to obtain the depression score. Here are some of the depression intensity scores predicted for the two methods on the three samples of the data. Next, we will take a look at a subtask called text summarization. For this project, we will look at both the extractive and abstractive text summarization. For extractive summarization, Deep AI text summarization API will be used. For abstractive text summarization, Hugging Face Pegasus libraries will be used. Here is the summarized text of a sample text using extractive text summarization. Here is the summarized text of a sample text using abstractive text summarization, which are trained on two datasets, XSum and Reddit TIFU. Next, we will look at the last task on emotion cause pair extraction. The aim is to focus on depressive emotion and the likely cause for it. Then, extract the emotion and the cause pair accurately in the context of depression. For this task, we will have two variants in the architectures for emotion cause pair extraction. These are the F1 scores on the different variant of architecture and also different datasets used. Lastly, we will look at the conclusion. Here are the sections that were being discussed in the presentation. Thank you.